The bag contains 3 marbles. 1 red marble, 1 blue marble and 1 green marble. When only 1 marble is picked from the bag, what is the probability that a red marble is picked out? Since there are 3 marbles, and only 1 is red, we have a 1 in 3 chance of picking out a red marble. Similarly with blue or green also. Therefore we can write the chance of picking out 1 red marble in 3 possible ways. As a fraction, 1 by 3. As a decimal, 0.33. As a percent, 33%. Similarly, we can write the chance of picking out 1 blue marble in 3 possible ways. As a fraction, 1 by 3. As a decimal, 0.33. As a percent, 33%. The chance of picking out 1 green marble in 3 possible ways. As a fraction, 1 by 3. As a decimal, 0.33. As a percent, 33%. Now let's see the experimental probability. The bag has only 1 red, 1 green, and 1 blue marble in it. Totally 3 marbles are there in the bag. Draw 1 marble from the bag. It is a red marble. Record the outcome on the tally sheet. Put the red marble back in the bag and draw again. This time you drew a green marble. Record this outcome on the tally sheet. Place the green marble back in the bag. Continue drawing marbles and record outcomes until you have drawn 6 times. Remember to place each marble back in the bag before drawing again. After 6 draws our chart will look similar to this. Look at the red column in tally sheet. Of our 6 draws, we selected a red marble 2 times. The experimental probability of drawing a red marble was 2 in 6. This can be expressed as a fraction, 2 by 6 or 1 by 3. As a decimal, 0.33 or as a percentage, that is, 33%. Similarly we calculate the experimental probability of drawing a blue and a green marble, and the values are recorded in the tally sheet. Now the values of experimental probability and theoretical probability are recorded in the chart. In this experiment, the experimental and theoretical probabilities of selecting a red marble are equal. The experimental probability of selecting a blue marble is less than the theoretical probability. The experimental probability of selecting a green marble is greater than the theoretical probability. If we just recall that an event is some specified result that may or may not occur when an experiment is performed. Now let's discuss more about events. An event having only one outcome of the experiment is called an elementary event. For example, if we toss a coin, we get only one outcome, either heads or tails. So P of heads and P of tails are called elementary events. P of heads equals 1 by 2. And P of tails equals 1 by 2. P of H plus P of T equals 1 by 2 plus 1 by 2. Equals 1 plus 1 by 2. Equals 1. Here sum of the elementary events of tossing the coin is equal to 1. Example 2. If we throw a dice, the events P of 1, P of 2, P of 3, P of 4, P of 5, P of 6 will have only one outcome respectively. This implies that P of 1, plus P of 2, plus P of 3, plus P of 4, plus P of 5, plus P of 6. If we throw a dice once, the probability of getting 1, that is, P of 1 is 1 by 6. Similarly for the rest all numbers, probability will be 1 by 6. Therefore P of 1, plus P of 2, plus P of 3, plus P of 4, plus P of 5, plus P of 6 equals 1 by 6, plus 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 1 by 6. This implies that 1 plus 1 plus 1 plus 1 plus 1 plus 1 divided by 6 equals 1. Therefore the sum of all elementary events in throwing a dice is equal to 1. Here we can observe that the sum of the probabilities of all the elementary events of an experiment is 1. This is true in general also. Therefore P of elementary event 1 plus P of elementary event 2 equals 1. Consider tossing coin experiment. P of heads plus P of tails equals 1, that is, P of heads plus P of not heads equals 1. Here not heads means tails. Therefore P of heads equals 1 minus P of not heads. This implies that P of heads equals 1 minus P of tails. In general, it is true for any event E, that is, P of E bar is equals to 1 minus P of E. Here P of E bar represents not E, and is called the complement of the event E. We also say that E and E bar are complementary events. Types of events. The probability of an event is a measure of the likelihood of its occurrence. Probability is always expressed as a decimal, and it will always fall between 0 and 1. Probability near 0 indicates that the event is very unlikely to occur. 0 probability, that is, P equals 0, indicates that the event is not sure to occur. So this event is called an impossible event. Probability near 1 suggests that the event is quite likely to occur. A probability of 1, that is, P equals 1, indicates that the event is sure to occur. So this event is called a sure event. If probability lies between 0 to 0.5, then it is said to be unlikely event. If probability lies between 0.5 to 1, then it is said to be likely event. The probability that an event E will occur is a number from 0 to 1, or 0 is less than or equal to P of E is less than or equal to 1. Let's see some of the events that occur in our daily life. The chance that you are going to eat dirt lunch, it is an impossible event. The chance of sun rises in the east. It is a possible event.